This is chapter 11, Water in the Atmosphere. What we are going to learn in this chapter is about the water content in the atmosphere. Now when you hear the word water, immediately think of water vapor. Water vapor is the gaseous state of water, and it is invisible to the human eye. In previous chapters, we have learned that air contains water vapor and it's due to evaporation. Sun energy directly falls over land and ocean bodies and makes it warm. Then water molecules, after getting warm, they rapidly move and vibrate, and then they quickly escape into the atmosphere as molecules of water vapor. Now a similar process also takes place in plants. We call it as transpiration. Again, here also, due to the heat from the sun, water content from plants evaporates through its aerial parts such as leaves, stems and flowers. So if you see, the important thing is the heat. Heat from the sun makes the evaporation process occur. Now there is another natural phenomena called as condensation and precipitation. Condensation is called the reverse of evaporation. A good example is you take a cold water bottle out of your fridge and keep it out for some time. You'll notice a change in the physical state of matter from gas into liquid. You'll see water droplets on the outer side of the bottle. And the similar thing happens in the atmosphere. When warm air rises due to evaporation, and as it goes higher and higher, it cools and loses its capacity to hold water vapor. That's how clouds are formed. Water vapor in the gaseous state turns into liquid. Once clouds are formed, the next step is precipitation. That means the water in the cloud will fall due to surface tension. And that's how rain, snow, hail occurs. So if I have to quickly sum it up, it all begins with evaporation, wherein liquid turns into gas, that is water vapor. After that, condensation takes place, wherein the water vapor, which is in gaseous state, turns back into liquid. And then precipitation takes place, in which water comes down on surface as rain, snow or sometimes as hail. Hail is frozen rain. So you see, now there is another physical state of matter, which is solid. With this, we know that water is present in the atmosphere in three forms: gaseous, liquid and solid. And more than anything else, you must understand that there is a continuous exchange of water between the atmosphere. And if you read here, it absolutely makes sense. It says, the ocean and the continents, through the process of evaporation, transpiration, condensation and precipitation, there is a constant exchange of water between the atmosphere. Now let's understand humidity in coastal region. Always remember this point. The amount of water vapor present in the air is known as humidity. That's why when you go to any coastal region during summer, let's say Goa, Chennai or Puducherry, you'll find these places to be very humid. You'll sweat like anything. And these places are at the same level as the sea level. And that's how you can see the sea right in front of you. Again, the point is that, as I said, when you have a large ocean body which is a sea in front of you, there the evaporation will be extreme. And evaporation is the rising of water molecules in the air. So naturally, the surrounding region will have an effect. In this case, it will have a lot of humidity. And that is how coastal regions are humid. Now we are going to quickly understand these terms: absolute humidity, relative humidity, air saturation and dew point. The first one is absolute humidity. I have told you the meaning of the word humidity, right? It is the amount of water vapor present in the air. Now when you look at the word absolute, it means complete, non-relative. In other words, we are talking about complete humidity present in the atmosphere. So the formal definition here says, the actual amount of water vapor present in the atmosphere is known as absolute humidity. Now if you recollect, water vapor is formed when water is warm. To warm the water, you need high temperature. That means temperature is an important factor in the formation of water vapor. However, when we calculate absolute humidity, we do not take an account of the temperature. That is what the meaning of the word absolute means. Only consider the humidity part in the atmosphere and not the temperature. It is calculated by taking the weight of the water vapor per unit volume of air. Now let's look at relative humidity. In this, we need to take an account of the temperature as well. Hence, we can say that the percentage of water vapor present in the atmosphere at a given temperature is known as relative humidity. As we know that temperature is an important factor in the formation of water vapor. That means if air temperature changes, then moisture will also increase and decrease. And that's why at sea level, moisture is high because temperature is high. And as the altitude increases, temperature drops and air loses its capacity to hold water vapor. That's how we conclude that change in temperature affects relative humidity. So relative humidity is greater over the ocean because that is where evaporation mostly occurs. And on the continent, that's not the case. So relative humidity is least over the continents. And the next one is air saturation. The meaning of the word saturation is something which dissolves or gets absorbed to a certain degree. Since here we are talking about air saturation, that means it is the air that gets dissolved or absorbed. Now the question is, what is the other thing in which the air gets saturated? Since this chapter is mostly about water vapor, that means air is getting dissolved or absorbed by the water vapor. So in other words, the air is incapable of holding any additional amount of water vapor or moisture. I'll explain this concept by taking a simple example. Take 2 cups of water and imagine one of the cups contain hot water and the other is cool. Let's assume that the right cup has hot water and the left has cold water. You'll notice that the right cup is steaming because it contains the hot water. Now you will not actually see any water vapor because the cups are not covered, rather you will just see that the water vapor is evaporating. Now evaporation also takes place in the left cup, but at a very less rate compared to the right cup. Now let's put a cover on these 2 cups. I'll draw some arrows that will represent different rates of evaporation. Since the warm cup is on the right side and it is evaporating faster, I'll draw 3 arrows which represents the rate of evaporation to be 3 times faster. Similarly, in the left cup, I'll draw 1 arrow which represents the rate of evaporation is 3 times lesser than the right cup. Now I have just given the numbers 1 and 3 randomly because the actual numbers are not important. The only thing that you need to understand is that the right cup containing warm water evaporates more quickly than the cold water. So in this example, both cups are half empty, meaning the remaining portion of the cups contain air. Since both cups are evaporating at different rates, water vapor will start to build up in the air above each cup. However, in the right cup, the air is not able to accommodate as much water vapor as in the left cup. This happens because air is saturated in both cups. But you will find more water vapor in the right cup, which has high temperature. That means the air in the right cup has saturated or dissolved and cannot hold any more moisture. That's why it condenses and returns to liquid form. With this example, I hope you have understood what air saturation means. Now let's understand dew point. In this basically you just have to understand what is dew. You have seen them on grass blades, then plant leaves and on stones during cold chilly morning. So basically dew are water droplets found on cooler surface. And they are formed from moisture, that is water vapor. Moments back we read what is air saturation, right? In that we saw there's a point at which the air becomes incapable of holding any additional amount of water vapor or moisture. Now that particular point, that exact point where the air cannot hold any additional amount of water vapor, because right after that point, water vapor turns into liquid droplets. And that's how dew is formed. So that point at which the air cannot hold any more water vapor is called dew point. So basically dew is water in the form of water droplets, and it exists due to condensation. And we know that condensation is the reverse of evaporation. So dew forms because of condensation. Now we will read about evaporation and condensation. I've already covered what is evaporation and condensation, so I'm not going to repeat again. Instead, I will just highlight few points, important points that will pretty much sum up this topic. So evaporation and condensation is the reason behind the continuous interaction of water and the atmosphere. In fact, the name of this chapter, Water in the Atmosphere, perfectly speaks that. Evaporation makes water turn into water vapor, or in other words, liquid to gaseous state. Then condensation is the reverse of evaporation, wherein water vapor converts back into water. In other words, gas turns into liquid. Now the temperature at which the water starts evaporating is referred to as latent heat of vaporization. Now look at this formal definition of condensation. It is the transformation of water vapor into water. So water vapor is vapor, which is basically gaseous state of matter. So the transformation of water vapor into water means from gaseous state back to liquid, which is basically reverse of evaporation. Therefore, we know that during condensation, heat is lost. When the air doesn't have the capacity to hold any more water vapor or moisture, that's when excess water vapor turns into liquid form. But then here it says, if the water vapor condenses into solid form instead of liquid form, then it is known as sublimation. Now, what could be the perfect example of sublimation? So here the perfect example would be hail. In Hindi it is called ole. Hail are ice pellets that are in the form of balls or pieces of ice. They are spherical and sometimes conical in shape. Since it is a piece of ice, therefore it is in solid state. So this is what is sublimation. Or in other words, water vapor transforms into solid form. Remember this. Now let's try to understand how condensation actually takes place. A very simple form of condensation is get a bottle of cold water from the fridge. Keep it outside for some time, you will see water droplets starts to form on the outer surface of the bottle. So what do you think is happening? Since the bottle has cold water inside, naturally the bottle itself will be cold. Now we know that there is moisture in the air, which is also called as humidity. If we look at the outer surface of the bottle very closely, air molecules in the surrounding constantly hits the outer surface of the bottle from all direction. Since the bottle is cold, the air right next to the bottle gets colder. So that means the air which already has moisture cannot hold any more water when it is closer to the surface of the bottle. And that's how moisture or water vapor transforms into liquid droplets. I'm sorry, I intentionally spoke in a fast and funny way. But that is pretty much what condensation is. However, I have a separate video on hygroscopic condensation nuclei. In that, I have explained properly in depth with illustration. So if at all you find it interesting, please have a look at it. I'll put the video link in the description. Now, before we wrap up on condensation, let's quickly look at some conditions, ideal conditions for condensation to take place. Condensation depends upon 4 conditions: volume of air, temperature, pressure, and humidity. And if you look at these 4 conditions, it absolutely makes sense. Because you need a certain volume of air that would carry moisture. And when this given volume of air exceeds its tendency of holding any additional amount of moisture, that's when water vapor or moisture transforms into water. So the first condition, volume of air, is absolutely necessary. The second condition is temperature. We know that temperature is essential for condensation to take place. When we say temperature, we mean low temperature. That is when the air containing moisture will come in contact with cool temperature, which will in turn make the air incapable of holding any additional amount of moisture. That's when water vapor turns into water. So temperature is also very important for condensation. Now the third condition is pressure. Well, if you see, even pressure is important. So water vapor is basically a gaseous state of matter. In order to make a gas turn into liquid or in solid form, high pressure is required. Because in a gas, molecules are far apart and moves freely. And in liquid, molecules are far enough, but they do slide over one another, and that's how liquid flows easily. In a solid state, molecules are tightly packed. That's what gives rigidity and hardness to an object. So in condensation, we know that water vapor turns into liquid as well as solid. Then clearly you can see that the gas molecules which are far apart, they would need high pressure that would bring them closer. Now in evaporation, that is boiling of water, there the pressure is low because when you boil water, the water molecule starts to expand and move apart from each other. So always remember this point. To move molecules apart, you need low pressure or hot temperature. And to bring them closer, you need high pressure or cool temperature. And you can also relate this to high pressure and low pressure system. Wind moves from high pressure to low pressure zone. And low pressure zone is an area which is associated with warm temperature. Similarly, high pressure zone is an area which is associated with cool temperature. So naturally, cool air gets attracted towards warm air. Because the cool air molecules are dense, meaning they are heavy. The moment cool air moves towards warm temperature, there they become free. Hence the conclusion is that you need high pressure to condense gas into liquid. And the fourth condition is humidity. Humidity means moisture. And we know that condensation is the reverse of evaporation. In evaporation, water turns into water vapor, or in other words, liquid turns into gas. And humidity means the amount of water vapor present in the air. For condensation to take place, warm air is needed, because warm air along with cool temperature and high pressure transforms water vapor into water. And that is what is condensation. So we can conclude by saying that condensation is influenced by these 4 conditions: volume of air, temperature, pressure, and humidity. However, the most important condition for condensation is the decrease in air temperature. If temperature is not cool, condensation cannot take place. Now once the condensation occurs, water vapor or the moisture in the atmosphere, it transforms into dew, frost, fog and clouds. So basically in condensation, the gaseous state of matter, which is the water vapor, it transforms into either liquid or solid state. Now let's briefly get to know about these liquid and solid state. The first one is dew. The temperature at which droplets form is called dew point. So basically dew is a water droplet and the first form of liquid matter, right, after condensation occurs, wherein water vapor converts into liquid. Now dew appears on stone, grass and plant leaves, especially during long winter nights. You can easily figure out that low temperature is required. However, the temperature should not be 0 degrees Celsius. It has to be a little above freezing point. Otherwise, we are not going to get a water droplet. Instead, we will get hail. Then high relative humidity is required because humidity means moisture and it is the moisture that condenses into water droplet. Then air needs to be calm because if there is high speed wind, then it is difficult for cold dense air to settle down. If cold dense air do not settle down, then condensation will not take place. So these are the ideal conditions that is required for dew formation. The next form of condensation is frost. Now where can you see frost? You can see frost in your refrigerator. So basically frost is the deposit of ice. Therefore the temperature must be below freezing point, that is 0 degrees Celsius. And if I have to put things into perspective, the temperature has to be below the dew point because in dew we see water droplets and frost is basically crushed ice. Hence, we can say that the ideal condition for the formation of frost is the same as those for the formation of dew, except that the temperature of the air must be below the freezing point. The next form of condensation is fog and mist. Now let's understand what is fog. Basically, fog is a form of cloud whose base is very near to the ground. In other words, fog is essentially a cloud at ground level. Now let's understand what is the difference between fog and mist. Fog and mist are almost same. After all, they are cloud containing water droplets. So the only difference is the visibility factor, meaning how far can you see through. If an area is covered with fog, then the visibility will be less than 1 kilometer. And if the visibility is greater than 1 kilometer, we call it mist. Now in urban areas and industrial centers, air pollution is a great concern. Now what happens is, the air pollutants, that is the smoke generated from urban and industrial centers, provide plenty of nuclei. If you have watched my video on how condensation takes place, in that I have explained what exists at the center of a water droplet. These are very small particles called as hygroscopic condensation nuclei that have the ability to attract water from the surrounding. If you haven't seen that video, I'll put the link in the description. Please have a look at it. Anyways, so the smoke from the urban and industrial centers become the nuclei which helps in the formation of fog and mist. When fog is mixed with smoke, we call it as smog. A fine example would be the smog in Delhi, which is causing severe air pollution. So moments back I said the only difference between fog and mist is the visibility factor. If the visibility is less than 1 kilometer, then it's due to fog, because fog is apparently dense. And if the visibility is greater than 1 kilometer, then it is due to mist. Now let's go a little closer and try to understand the exact properties of fog and mist. I want you to understand this in a step-by-step manner. Both fog and mist are a form of condensation, right? So naturally there has to be water droplets in the air, because condensation is reverse of evaporation, wherein water vapor, which is gas, transforms into liquid form. That means both fog and mist have water droplets. However, the surface tension on these water droplet is low. That's what makes them fall slowly in the case of fog and mist. But if you look at rainfall, which is also a result of condensation, in that surface tension is high, which makes the water droplets fall, and we call it as rainfall. I hope so far you have understood that fog and mist have water droplets with very low surface tension. Now, if you have seen my video on hygroscopic condensation nuclei, in that I have explained that tiny particles of dust, smoke and salt exist in the form of nuclei, and this is what holds a water droplet. That means at the most basic level, both mist and fog contains nuclei, which are these tiny particles. Therefore, to understand the difference between fog and mist, we will have to understand what happens in and around these nuclei. Here is what happens. Both mist and fog contains moisture, that is water molecules. However, the layer of moisture is thick in the case of mist. When we say layer of moisture, that means the water coating around the nuclei is thick and white. That's why when you take a walk on a misty morning, you'll notice water droplet on your jacket. When it comes to fog, fog is basically a cloud at ground level. Fogs are drier than mist. That means the layer of moisture around the nuclei in the case of fog is not thick. When there is less water content, that means moisture content will be less, and this is exactly what happens in fog. And that's what makes the fog light and dry, causing poor visibility. Because if the moisture content is low, then the nuclei in fog will float in air for a longer duration, and that's what causes poor visibility. And the fourth form of condensation is cloud. In this video, many times I've said that rainfall and cloud are a result of condensation. Now I'll quickly tell you how clouds are formed. When we look at a cloud, it looks like a white, fluffy, gaseous thing that moves around in the air, right? But then clouds are actually a large mass of tiny water droplets consisting of liquid water and crystals of ice, formed by the condensation of water vapor in free air. Let's look at the cloud formation process. At first, the heat from the sun warms the ground. That makes the surface of the earth warm and also the surrounding air. Now warm air rises from ground level. And we also know that air around us contains water vapor or moisture. So when warm air rises, it also takes the moisture along with it. As the altitude increases, temperature decreases. So naturally, the temperature of the water vapor or moisture content in the air drops as the height increases. At higher altitude, due to low temperature, warm air cools. Now what happens is that the air becomes incapable of holding any additional amount of moisture. Now another thing that you need to understand is that air also contains tiny minute particles of dust, smoke and salt, which are also known as aerosol. So there's a term given to the aerosol. These are known as hygroscopic condensation nuclei. Now these aerosol have an amazing property of attracting water molecules in the air. And that's how water vapor gets attracted to aerosol and then sticks to these tiny particles in the air. Since these aerosol or hygroscopic condensation nuclei are present in atmosphere in huge quantity, therefore they become the surface for the water vapor to fall onto when water vapor condenses due to low temperature. Let's go a little more deeper. When air cools, it cannot hold any more moisture. Then what happens is the excess amount of water molecules get attached to the hygroscopic condensation nuclei or the aerosol. When enough water molecules gather around the nuclei, a cloud droplet is formed. These cloud droplets are very small, and when they are combined in huge number, a big white fluffy cloud is formed that can weigh in tons. Now these cloud droplets are so small that they float in the air as a cloud. And when these cloud droplets combine to form larger drops of crystals, they become too heavy. And due to surface tension, these droplets gradually fall from the sky as rain. Now based on height, size, density and transparency, clouds are grouped under 4 types. Let's get to know each one of them. The first one is cirrus cloud. They are formed at high altitude, which is around 8 to 12 kilometers horizontally upwards, almost at the height of Mount Everest. Now they look something like this. I'll put a picture of it. So if you look at it, these clouds are very thin and they look like feather. And since I've mentioned that they are formed at greater heights, so naturally the temperature is going to be very low. That means these clouds are composed of ice crystals. In other words, as I've said that clouds are made up of these tiny water droplets, so these droplets are in the form of ice crystals. So this was the first type of cloud, which is called as cirrus cloud. The second one is cumulus cloud. Now these clouds are formed at a height of 4 to 7 kilometers. If you see, the height is lower than cirrus cloud, but still 4 to 7 kilometers is very high up in the sky. I'll put a picture of this cloud as well. Now these clouds are fluffy like a cotton, but then they have flat base. It looks like as if a piece of cotton is floating in the air. And if you look at it carefully, somehow it also looks like a cauliflower. Now these clouds usually appear in patches and can be seen scattered here and there. Since this cloud is bigger than cirrus cloud, therefore it may or may not produce rainfall. Since this cloud exists in small patches, If at all they come close and combine to form a big cloud, then chances are it may rain heavily. And one more thing you need to understand is that cumulus clouds are bigger than cirrus clouds. That means more water vapor, more water droplets or ice crystals exist within these clouds. Alright, so this was the second type, which is the cumulus cloud. The third one is stratus cloud. Now, stratus means existing in layers. That means these are horizontal layered clouds that cover large portions of the sky. Here's a picture of it. These are also known as low altitude clouds, meaning they exist at a height of less than 2 kilometers. They are found in white and grey color. Since these clouds are found at lower altitude, they even come down on the surface of Earth in the form of mist or fog. So we can also say that stratus cloud are like fog that doesn't reach the ground. As I said, they appear in white and grey color and they exist in layers. So what happens is they do not allow the sunlight to pass through it, making the day look dull and dark. The fourth and the last one is nimbus cloud. Now these clouds are black or dark grey and they exist in the form of layers just like the stratus cloud. But they cannot be called as stratus cloud. Have a look at this picture. These clouds are formed at low altitude, around 3 kilometers or so, and sometimes they are very nearer to the surface of the Earth. Since I've said that these clouds are black or dark grey in color, that makes them dense and these clouds block the rays of the sun from reaching the surface of the Earth. Nimbus clouds do not have any specific shape. However, they are thick and dense, so naturally it consists of large amount of water vapor. Now we will go to the next topic, precipitation. So far we have learnt what condensation is. Now precipitation is a direct result of condensation. If condensation is the process wherein water vapor transforms into water or solid, then precipitation is the part where these condensed water droplets fall onto the Earth's surface due to surface tension. So this line over here is absolutely correct. It says, after the condensation of water vapor, the release of moisture is known as precipitation. So precipitation takes place in the form of liquid as well as solid form. If it is in liquid form, we call it rainfall. That means the temperature has to be above the freezing point. And if precipitation takes place in solid form, then we call it snowfall or hailstones. And here the temperature has to be lower than the freezing point. Just remember this point. In the case of snowfall and hailstones, the temperature has to be below the freezing point. Which means naturally the altitude has to be higher because higher we go, the colder it gets. Now let's go to the topic types of rainfall. Rainfall has been classified into 3 main types. Let's quickly get to know about each one of them. The first one is convectional rain. So here it's written conventional. Actually it's not conventional, it's convectional. So there's a typo mistake. When you see the word convectional, does it remind you of the term convection currents? Convection currents is basically transfer of heat energy from one place to another. It takes place within gases, liquid, and even in molten rocks. You'll find convection currents in Earth's mantle where the heat of the magma is released upwards towards the lithosphere. Then convection currents are found in the atmosphere when sun heats the land surface, making the surrounding air warmer, and warm air rises and reaches troposphere, which is comparatively cooler. Now that you understand the meaning of the word convection, convectional rain occurs when the sun energy heats up the land surface. It also heats the surrounding air. And we know that warm air rises, and the rising of warm air forms convection currents because you see there's a transfer of heat energy. And naturally when warm air rises higher in sky, it starts to lose heat, and that's how condensation takes place and clouds are formed. Once the clouds are formed, subsequently rainfall takes place. So if you see, it all starts with warming of air. For that, the ideal weather condition has to be during summer season. And the ideal location has to be equatorial region because we know that equatorial region receives sun rays all throughout the year. And if we go a little further, convectional rain is very common in the interior parts of the continent because land surface heats up faster than water surface. And the last line says it particularly takes place in the northern hemisphere. If you look at the world map, northern hemisphere has a lot more land than the southern hemisphere. As a result, the northern hemisphere heats up faster during its summer than the southern hemisphere during its summer. So this was all about the convectional rain. The next one is orographic rain. Now when you see the term orographic, you should immediately think of orogenic processes. If you remember class 11 chapter 6 geomorphic processes, in that we came across a topic called diastrophism. I have a video on diastrophism. If you want, you can check it out. I'll put the link in the description. Now within that topic, we saw this term called orogenic process, which is basically mountain building process. When crustal plates move horizontally, they either come closer or they move apart, or sometimes they slide past each other. And mountains are formed when two crustal plates come closer, in which one has to slide under the bigger plate, which makes the land surface to elevate, and that's how mountains are formed. So this is what is orogenic process. Now here it says orographic rain. That means the rainfall has to do something with mountains. The key element over here is the mountains. Now let me explain this orographic rain with an illustration. I want you to pay attention. It may get a little complicated, so I'll go in a step-by-step manner, try and understand accordingly. Alright, we know that both the land and water surface gets heated up due to solar energy. We will take the water surface because that's where evaporation is intense. So evaporation is basically rising of warm air that contains water vapor. When warm air rises, it does not rise in an absolute straight upward pattern because there are winds that flow horizontally, so somewhere the direction is a little sideways. Now the exact answer for this can be found in the laws of thermodynamics. So what the laws of thermodynamics tells us that heat moves from areas of higher temperature to areas of lower temperature. That means heat can move anywhere, up and down, sideways, depending on the situation. And the situation is the temperature difference. So temperature difference is really what drives heat to move in any given direction. Now we know that land surface heats up faster than water surface because land is opaque. Likewise, land loses heat faster than water. Now coming to the land surface, the top portion of a mountain will heat up faster and also lose heat faster than the valley floor. And that's what makes the mountains cool. Now the warm air of the ocean, when it rises due to evaporation, it moves towards the colder region. Now we know that troposphere is cold, but it's very high up in the sky, somewhere around 10 to 12 kilometers high. Before the warm air reaches the troposphere, at the mid-altitude, warm air gets attracted towards the colder region that exists at the top of a mountain. Of course, the warm air also gets a push from the horizontal moving wind. So overall, the warm air gets a push to move upward along the slope of mountain. Now warm air then starts to cool because atmospheric pressure decreases with altitude. As the warm air begins to cool, the water vapor present in it starts to condense. Clouds begins to form. Then rainfall occurs. As the air reaches the summit of the mountain, it begins to descend. While going up along the slope of a mountain, temperature falls, and while coming down, temperature rises. Automatically, the air's capacity to take in moisture increases because at warm temperature, air can take in more moisture. There will be no rain at this side of the mountain. This area is known as the rain shadow area. So basically you see in orographic rain, warm air is forced to cool when it rises over relief features like a mountain or a hill. As the warm air rises along the slope of a mountain, it cools, condenses and forms rain. This is what is orographic rain. And if I have to ask you where can you see orographic rain in Indian subcontinent, then you should immediately think of the mountains in Western Ghats. Because when the southwest monsoon arrives in Indian subcontinent, the monsoon winds have to face the hills and mountains of the Western Ghats. Likewise, Himalayan mountain range also blocks the monsoon winds. And at higher elevation of Himalayan range, it rains heavily. If you all remember the 2013 Uttarakhand disaster, wherein a sudden cloud burst event led to flash floods and landslides, that is a very good example of orographic rain. So I hope now you understand what is orographic rain. The next one is cyclonic rain. Now this topic has been covered in the previous chapter, which is chapter 10, Atmospheric Circulation and Weather Systems. I did not cover this topic in that video, I'm going to do it here. So let's quickly understand what is cyclonic rain. So far we have read about two types of rainfall. That is convectional rainfall and the other one is orographic rainfall. And we have also seen the mechanism behind it. In convectional rainfall, the sun energy hits the Earth's surface, then the surrounding air gets heated up, then warm air rises, it starts to cool. When it reaches sufficient altitude, after losing heat, moisture in the air condenses into liquid and solid droplets, giving rise to clouds. And finally, due to surface tension, these cloud droplets fall as rain. In orographic rainfall, warm air is forced to cool when it rises over relief features like a mountain or a hill. So in this type of rainfall, a physiographic feature like a mountain or a hill is the key element, without which orographic rainfall will not occur. Now coming to cyclonic rain, here the rain is caused by cyclonic activity. And if you see, what is a cyclone? It is basically a large scale of air mass that rotates around a low pressure zone. Because always remember, wind moves from high pressure to low pressure zone. So clearly here we are talking about two winds of different temperature. One has to be warm and the other has to be cold, because high pressure and low pressure areas are formed due to temperature differences. Because we know that sun energy do not reach all parts of the Earth's surface equally. Now we also know that moisture exists in warm air and cold air is dry. The region where warm air and cold air meet, it is called a front. Like this, we have two fronts. One is warm front and the other is cold front. At the warm front, air rises, and at cold front, air sinks. So naturally, the light warm air will rise gently over the heavier cold air. And then we also know that troposphere has low temperature. That will reduce the temperature of the rising warm air. And the moisture present in it will start to condense. And that will lead to formation of clouds and thereafter rainfall. So basically, cyclonic rainfall is caused when two air masses of different temperature meet. Always remember, warm air and cool air do not mix, as they have different densities. As a result, when they collide, the warm air quickly rises over the cold air and starts losing heat. The moisture in it condenses to form clouds and then rain occurs. So this is how cyclonic rainfall occurs. Let's read about the last topic of this chapter, world distribution of rainfall. What I'm going to do is I'm simply going to state the facts that are there in this topic along with some pictures, and that should be enough to cover this topic. Alright, the first one is different places on Earth's surface receive different amounts of rainfall in a year, and that too in different seasons. And the best possible reason for this statement is that we all know that rain is a byproduct of condensation, and condensation occurs if there is evaporation. For evaporation to occur, sun's energy is required, so that it can warm the Earth's surface, and that's how warm air will rise, which will further go on to condense and form cloud, and ultimately lead to rainfall. And we also know that not every place on Earth receive equal amount of sun rays. As you go away from the equator, these sun rays become more slanted or curved, due to which the amount of sun rays and the light received by higher latitudes are less. This develops uneven heating pattern between land and water at different places. And that's how different places on Earth receive different amounts of rainfall in a year. The second one is, as we proceed from the equator towards the poles, rainfall goes on decreasing steadily. One good possible reason for this statement is that the level of humidity decreases as we go away from the equator. Because we know that as you go away from the equator, temperature drops. At low temperature, you barely have any moisture. Cold winds are dense and they are usually dry. On the other hand, warm winds have a lot of capacity to hold moisture. And through this entire chapter, one thing we must be clear about is the fact that moisture is essential for condensation, so less moisture leads to less rainfall. The coastal areas of the world receive greater amounts of rainfall than the interior of the continent. Now let's find a possible reason for this argument. Since rainfall is a direct result of condensation, and condensation only takes place where there is evaporation, and evaporation is maximum at water surface, because that is where sun rays can warm maximum water molecules that will go on to become the much needed moisture. So if you have ever been to any coastal region, you will find the place to be very humid, because the sea is right in front of you. So naturally the effect of evaporation will be felt at nearby landmass. Here it says the latitudes 35 degree and 40 degree north and south of the equator, the rain is heavier on the eastern coast and goes on decreasing towards the west. But then between 45 degree and 65 degree north and south of the equator, due to the westerlies, the rainfall is first received on the western margin of the continent, and it goes on decreasing towards the east. So if you look at this picture, you can clearly see that in between 30 degree and 60 degree north and south, we have the westerlies. So westerlies are these wind that travels from west to east. So naturally, if you look at the direction of the westerlies, it is obvious that the rain cloud will go towards the eastern side and it will cause heavy rain in eastern side. But then westerlies begin from west, so the initial point of rainfall has to be on the western side of the continent. And the next point says, wherever mountains run parallel to the coast, the rain is greater on the coastal plain, on the windward side, and it decreases towards the leeward side. So the answer to this argument, you'll find it in the topic orographic rain. Just go behind and see the topic again and you will understand. And this last topic on world distribution of rainfall, I'll cover this topic in a separate video, or I'll just create a map and put it on the Instagram handle of this channel. So make sure to visit there and you can have that map. You can download it and use it for your own reading purpose. So with this, I've covered everything in this chapter. The question answer of this chapter is available on the website. The link is there in the description. I hope you found this video helpful. Let me know your thoughts in the comment section. Thanks for watching and I'll see you in the next one.